I'd like to introduce Iftak Schulman. He's our founder and CTO at Redis Labs. Scott, come on up.
Thank you, Dave. Can you guys hear me? Cool. All right, so real quick, thanks to everybody so far for first coming out, being in the snow. I came from Silicon Valley a couple days ago, and I think I left and it was like 65 degrees, and came here is 25 degrees. So I'm all wearing like snowboarding socks and stuff like that, trying to stay warm up here. But I work at Twilio. Twilio is a telephony company. So if people have ever made a phone call, Twilio is a way of doing that through APIs. We also have a bunch of other stuff like SMS and a bunch of other things that you go online and look at. This talk isn't really about Twilio. It's more about the way that we use Redis and how some kind of patterns actually help to make that either easier for your end users, internally, externally, et cetera. So today we're going to talk about the happy marriage of Redis and Protobuf, talk about how to basically create a key space, what Protobuf is if no one's actually heard about Protobuf before, and then talk about how to actually pull data in and out of Redis in a way that's kind of abstracted. So without further ado, this is the same thing I just said, only I'm going to go into a little bit more detail. So, protocol buffers. Has anybody in the room actually heard about protocol buffers, Protobuf, gRPC? Awesome. This is good so far. Usually I have to describe a little bit more about that. So protocol buffers is basically just like a data exchange format. If you've used like Avro, for people who don't know about Protobuf, or if you've used any kind of thrift technology, or Apache Arrow, which is kind of trying to basically steal protocol buffers thunder. It's just basically a way of exchanging data in kind of a language agnostic way. We're going to also talk about Redis key patterns. So before we talked about basically there was ACLs bound to namespaces coming out in Redis 6. For people who have no idea that what was coming out in Redis 6 like me, I now know. So some of these patterns are going to basically show how to do things now, and then you can kind of just throw them away and move forward into Redis 6 without having to worry so much about writing abstractions on top of things. Then we're going to also talk about how to actually, do the true marriage of Redis and Protobuf. So basically said together for, together forever, or at least for now, like a lot of marriages, it's happy now, might not be happy later. People move on from languages and everything else. But aside from all that, will not be depressing. It's optimism. So we're going to go through kind of mental models and things like that. So protocol buffers. For the hands that weren't raised, protocol buffers themselves are basically just like a message format. So if you ever used, if you ever written something with JSON, or if you used, JSON schema, or if you've written like a MySQL table, you're defining data. That's all protocol buffer is basically a definition of data, but it's actually strictly typed. So for a lot of people who don't like strictly typed languages, I'm sorry, but for Protobuf, it's strictly typed. But it's also there for good reasons, because you can actually measure the size of the actual data you're storing. So if you think about Redis, Redis is in memory. You can put it in Flash as well, but if you have memory, you don't want to run out of memory. So with Protobuf, you can actually think about, what does this use case cost in terms of storage space? And you can actually test all of that just by creating Protobuf, compiling it, and then you can also figure out just by saying like .serialized size. It actually tells you the serialized size for the overhead. You can also use object debug from the actual Redis command line interface to actually to figure out once something's in Redis, what is the overhead of that object itself? Because you might actually get some extra compaction on top of that as well. So protocol buffers give you strict types and compile time guarantees. At Twilio, we actually take all of our protocol buffers, and the same way that you'd write like an external library for your Java, your Scala, your Python, et cetera, you have unit tests. So for our data, we unit test our data. That means that when we change our data, we don't have to worry about some downstream system we didn't think about not actually working when we release a new version of an internal API or an external API. At the end of the day, your systems are only as good as how they work. So being able to actually version data and test data means that you can actually test all backwards compatibility. One of the other things we do also is that for every single mutation, every single change, we actually keep a backlog of every single binary version of that data so that your unit tests can actually backtrack and ensure that every single version of that actual data can be tested back through the new compiled version of your protocol buffer. Given that protocol buffers are basically kind of like a POJO, and it gives you ways of basically reading binary data for serialization and deserialization, you can actually test all this stuff, which is cool. It's also interoperable with many different languages. So instead of saying we're only doing Node.js or we're only using Python, this is basically allowing the abstractions to continue. into any new language. A lot of companies are, Java now, maybe they're going to Go, maybe they're going to Rust, it doesn't really matter. This basically allows you to kind of move forward, take your data with you. Even if you wrote it, back in like, 2006. You might still use it now, just in a different language. All right, so more about Protobuf. So we basically have an idea of basically what a builder looks like. If anyone's written a builder before or has used a builder, they're kind of cool. The pattern itself used to be like really, kind of a de facto for writing immutable structures in Java prior to any kind of real immutability. So you basically had private constructors, and you have basically a public inner static class that helps you kind of build an object. With Protobuf, you basically write a .proto definition, compile it down, and you get everything else for free. So for people who are lazy, like every engineer, this actually allows you to basically be lazy, but be lazy with actual good reason. So instead of having to worry about writing a bunch of different POJO definitions, taking that and putting it into a different library, trying to share that library, hopefully that it's going to work with each different version of Java. Maybe it's not going to work with Scala because you don't have the right methods. It's not going to work with Python, so you have to write a different library for that. In this case, you basically write a single definition, and then you can use it wherever you want to. So optimized message formats is also a big deal. So if you think about going back to the whole thing about how Redis is memory, if you're storing data structures, so if you're storing structured data inside of the data structure store of Redis, then being able to basically serialize back and forth is actually a really good thing, because you need to be able to have a quick marshaling of that data. So I have down here on the bottom of the screen basically what our serialization and deserialization looks like. How many people here have written like an object, have worked with basically an object stream or anything else inside of Java? All right, sweet, a couple hands, that's good. So serialization can be difficult. It can be ripe for error depending on what you're actually trying to pull out. In this case, you know exactly how things are going to be serialized or deserialized, so it basically gives you a guarantee of how that's going to actually work, which is a good thing. So guarantees are good because it allows you to actually rely on things. So this thing I usually like to talk about, so people like it when things actually work on releases. How many people here have had any experience with a bad release? Good. Probably everybody in here has at least known about a bad release. I work in basically streaming pipelines, so I'm usually talking about like Apache Spark, but on our API sides, we actually use Redis streams that get into our Apache Spark pipelines. But we also, in our API side, we're doing like gRPC. So everything's basically protobuf in, gRPC, which is basically just Google remote procedure call. So everything is basically API definitions written in protobuf. The actual messages are being passed through in protobuf, and then responses are in protobuf, and then everything that gets into like our streams is all protobuf as well. So it allows us to basically have end-to-end kind of reliability on data that's actually passing through our entire systems, which is also good, because then you don't have like 1,000 different ways of reading a specific message from like a streaming pipeline. Also in an API, if anyone's ever worked with either front-end developers or that you have been a front-end developer, changing APIs happens all the time. I'm a back-end engineer. We sometimes don't think about what's going to happen when we make a change. And if we don't have really good unit tests that actually say, the API contract hasn't changed, like an integration test, then things go wrong downstream, and then you have, broken UI. So don't have broken UI. The other cool thing about Protobuf, which I didn't really mention yet, is that it basically supports backwards and forwards compatibility. So if you want to actually change things or add new fields, and you have, say, like 1,000 different servers that are actually running with the same kind of protobuf definition, you don't have to basically shut down everything, update all your servers, and then take it all back up online again. So you can actually have like a zero downtime deploy and still basically kind of roll that stuff through. So you can canary test new changes, and then you can actually kind of roll out a whole entire fleet without having to worry too much about it. So backwards and forwards compatibility is something that's useful. Being able to be lazy and compile down your messages is a good thing as well. And then also, using it for pipelines and everywhere else in the company means that there's a couple less things that people have to do, and they can just rely on a shared data libraries. Lastly, also, it speaks JSON. So there's a protobuf library that ships from Google that basically reads your protobuf either from JSON or to JSON. So if you want to throw that into Redis JSON, then you have the ability to do all that as well. The nice thing, though, is that you have a defined actual format that doesn't change. So your JSON will always be exactly the same between releases, which is great. And I already kind of covered the other part about how you can do gRPC end-to-end, or you can also do JSON end-to-end and still ensure that your API definitions are all bound to individual protobuf formats, which is cool. Then there's also just some code over here showing some of the actual protobuf 3 methods for basically parsing or printing from proto to JSON. These slides will be available later if anybody wants to go kind of download them. I think we're going to make them available afterwards. So I got to go so I don't basically talk too much about just protobuf and don't go into anything else. So here's basically more, this is Scala. Good stuff over there, but it's basically just kind of showing another way of being able to basically read from a type that's bound to a specific underlying data type, even though it's kind of JSON coming in. I can talk to people more about this later. All right, so we talked about protobuf. That's great. So now there's a way of basically having data, and there's a format for that. Data types, this is great. We also have Redis. So who here uses key space patterns or anything else with their Redis? So I see a couple hands. This is all good. If you think about organization of your kind of key space, you can basically think about organization of your key space in the same way that you'd actually build an API. So I'm going to talk a little bit about how we write keys into our key space, and then reasons for doing that, and then also tell you reasons why, even if you do that, you don't have to do as much on top of that because of now the new stuff in Redis 6, like ACLs. But namespace is basically a way of kind of, if you're sharing a huge Redis cluster, you might have, multiple gigabytes, terabytes, et cetera, in your Redis cluster, but you also might have different namespaces. So inside of Twilio, I'm on the voice insights team. We might have a messaging insights team. We might have a different, different team. Doesn't really matter. That namespace is basically bound to that team to restrict a collision. So if you have a collision in your namespace, you might have the wrong data, and then everything breaks. So namespace basically gives you that kind of root key that's bound to a specific property or entity within the company, or even just helps you kind of organize your data. And I can go into more stuff like that, but we probably won't have time for it. So versioning, things change. If you have an API, you know that you've actually probably released different versions of that API. In your key space, if you don't version your key space, you're not going to really have an easy way of telling which key is bound to which underlying type of data. So versioning that individual key space also helps you version the underlying data so that you're not trying to read binary data and deserialize it into the wrong format. This allows you to also kind of change, if you had a bad idea early on and you want to now move to a different data structure, that's okay too. You might have a different protobuf version or a different protobuf data type stored within a specific key. It allows you to do that. So data category is kind of, a lot of people will usually just call this a name. So if you have basically a namespace and you have a version, then you have a category or a name. It's a way of basically creating like a root key to a specific type of data. So it's a logical data collection, and it's data stored at a key within that collection. If you think about like a SQL table, this is the same exact thing. I'm going to go through basically an example of connections pretty soon. So data category would be basically connections or connection. You think about plurality, like in an API. Same kind of thing if you want to think about that as a mental model. All right, identifier. It's a UUID. It could be a string identifier, like a connection at a specific endpoint in an Amazon region, which is what I'm going to show in just a second as well. So identifiers are basically saying that if you have a key space and you have a type of data in that key space in that category, that it's going to be identified by something. All right. So setting it up two examples. So the company that I work at is an API company. People have to connect to us to be able to actually trigger an event or make a call or send something. So this is basically just showing like a typical map if you think about like Amazon regions. It could be the same thing for Google regions, Azure regions. Doesn't really matter, but it's points of presence. So if we're selling communications as a service, we have points of presence to basically ensure that we're reliable. So if we have a message called connection, we have a long value, which is the uint64, which is an unsigned 64-bit integer, as created. So if you think about a timestamp. We might have a UUID, which is denoting that connection. Then we have a connection group. Connection group is basically another message type that denotes where we are connected to, and then it also has room for growth in the future for any other kind of connection details. Also device types is, are we connecting with a phone? Are we connecting with an API? Is this connecting with another connection, et cetera? You think about chainability in messages and creating generic types. We also have geo points. So you think about geo-radial indices and things like that. You can actually figure out how to kind of pinpoint what's going wrong potentially within connection groups within specific geo areas. So this is kind of an abstraction showing what a connection is. So assume that a connection is one of many events that we store in the company, but everything starts with a connection. So if we have connections, we've got a root key. So right now we have basically VI for voice insights, V1 for the version of this individual key space. Connections is the plural kind of root key for our connections. We have a connection data type. So a list of connections or many connections is basically makes a lot of sense as having a sequence or a set. In case of the actual underlying connection, we know that we have zones of presence. So for that, all we have up here is basically we're doing a set add because we know that we're going to only have one specific point of presence within our connection group. We don't want to have a bunch of US ones because then we don't know what we're going to basically group in. So if you think about this as an API, you'd have like a V1 connections. And our API endpoint might be like voiceinsights.twilio.com. So it thinks about, here's an API to my key space. All right, I think I pressed, there we go. On to the next part. So if you think about like drilling down from like a universal set of connections into a subset, which is only US1 connections, one of the things that we do at the company is basically use our key space almost as a way of identifying what exists in almost like a discovery mode. So things are documented, but you might also add like new points of presence. So as they become available, they also automatically become listable. So this is just kind of showing further the point of saying we have connections, now we have a subset. So we're going to go into what the subset does. So if we have a subset of connections within US1, we're going to now have basically a connection object again. This one's showing basically a timestamp, showing UUID, and it's also showing basically like a shortcut to a zone being US1. So the connection, we're going to basically store it as a time series set. So this is going into a sorted set. Could also go into a Redis stream. This is basically saying from our data, we're throwing stuff into the US1 zone. Our created time is basically the date time that we actually created the actual object, and the UUID is actually our identifier. This is basically now creating a breadcrumb to an individual data point. So this is basically just a way of saying, here's the key, so now go find the key. Do you want me to go back? I saw a picture taking. Cool. All right, so if you have a key and it's a connections key in a specific region, then you also have the ability to say, well, we have a connection, and that connection actually has a UUID. So if we have connections plural, there's also an individual object, which is a connection. And the connection is bound by that UUID. So same thing is still namespace, version, data category, and then our identifier. So in here, it's basically showing that if you have a connection type, you can basically create a byte array and now store the binary bits inside of the actual key. So on the bottom, we basically just show like the simple key. So setting the key from the bytes, and then if you want to add like retention seconds or anything else, that's stuff that's either added directly to your business logic, or I'm going to show a different pattern for that in just a sec. Also, same thing with an API. V1 connection, UUID, would be a way of kind of listing this if you had an API to fetch data out of your Redis, Redis database. All right, so the Redis key pattern is something that's first started at Yahoo when I was there back in 2011. And we were using Redis at that point. It was like Redis 2.4, so kind of way back old school Redis compared to where we are now. But the Redis key space is basically a way of saying that we have protobuf objects that represent a key. The key can basically be within a namespace. It can be versioned. There might be a data type stored within that key. And then that category type is basically kind of mapping out to where this key is actually bound to. You might have attributes, you might have a UUID. This thing might be extended to fulfill different requirements in the future, but you can still know that you have a primitive, which is a Redis key that's actually available in your code. You can also extend it for GDPR. So if you have basically, say it's a list of attributes and an attribute encapsulates a field that's either going to be sanitized or it's going to basically be encoded with a specific kind of encryption. All that stuff can basically go into the Redis key, and then basically on the server side, when you're going to write a key, everything can be done through an abstraction layer as well, so that every team doesn't have to handle GDPR capabilities and things like that. So if we have a Redis key, which encapsulates how to create a key and what data is stored within a specific key, a trait, are people familiar with Scala here? A trait is no different than like an actual interface, like in Java. It's basically like a construct of what a class should represent. So here we basically have Redis keys. So we know it's going to basically have a namespace, it's going to have a version associated with it, and that's going to have different kind of abstractions for creating keys. I'm going to skip ahead because there's only 5 minutes left. So if you have a Redis key and you have Redis keys as a kind of primitive for actually building Redis keys, you're probably also going to have a type registry which denotes how types are associated with a specific underlying type of key, and how to parse that data from its binary serialized structure, and how do you deserialize that back into something that you can work with inside of your source code. So mix it with Redis keys to be able to make powerful Redis interactions. If you're using Proto 3, you already have a type registry in there as well. So they've actually already brought the type abstraction to the table. And I'll have an example of that in just a sec as well. Then there's also the notion of basically Redis data source. So if you use like Jedis or you're using other kind of connection libraries for Redis, you already have the ability to basically say, like, we can connect to Redis. But you might also want to abstract away that connection, pulling stuff from like a Jedis pool or pulling things from a pooled resource, handling an abstraction that says, this namespace is actually pointing to this individual backing Redis database. Lots of different things that you want to do if you want to make things easy for like an end user. I usually work on platform teams, so a lot of stuff that I do is basically building things that help other people not have to work as hard. So putting it all together, basically we have a key space generator, which is Redis keys, with the ability to basically create like some kind of source connection. In this case, you can basically take our type registry, mix it with Redis keys to be able to say that a specific key pattern only stores a specific type. And then I want to actually validate that that type is the only thing being written to that key space, whether it's a string or whether it's a connection or any other type of object. So here's kind of the full source code of what it would take to basically write a key and then fetch a key back out of a Redis connection through this abstraction. So basically, we have our connection. We saw that before. We had the zoned US1. So within our actual source object, let me just go back to that. So we have source, which is a Redis source. So a source object has Redis keys internally to it. We say, I want to key for this data category.connection, which is an enum. So the use of enums in Protobuf also allows you to basically have a compacted, smaller size object once it's been serialized. So you're also saving space in Redis. And that's saying basically get the connection UUID, which will end up being a connection object. So you can either put a connection with the key in the actual object, or you can go and fetch an object back out again and saying, I want to fetch this connection type. All it's doing is basically taking the binary data stored within that key. It's basically extracting it, it's parsing it, and then it's basically sending it back so you can work with it within your underlying API. Or in this case, wherever you want to pull this from. Whether it's an abstraction layer from Python, someone's written from a different language like Scala, doesn't really matter. The data is basically interoperable between different types of languages or different programming languages. So source, fetch, connection, key, and then in Scala you have something called pattern matching, which is the same thing as basically just testing like the result type. So in this case, a success with a connection gives us that actual object. Otherwise, a failure is going to tell us that we got to do something different. All right. So if you think about abstractions over Redis, you have things like sorted sets, or you have a Redis stream. For a lot of those things, you basically think about like I'm listing something. For a lot of APIs, you're basically doing pagination, or you're doing other things where you basically just want to take a look at header tail. So in this case, source list sequence of connection, which is just an iterable. So we're saying we can get many different connection objects. In this case, pass a key, a direction, whether it's descending or ascending. Think about like SQL. A lot of people understand SQL. People might not know if you say up or down or head or tail, what that actually means. So we use a lot of the same kind of nomenclature as you would within SQL. Then execute allows you to basically say, I want to create a bunch of different commands. They're going to basically be either lazy executed or directly executable. So if you're familiar with like futures or like eventual computation, a lot of this stuff kind of follows that same pattern. If you build it that way, you could also not build it that way as well, which is all great. And then here's some actual Scala code for people who like Scala code. This is basically showing kind of a Jedis abstraction. So we're saying, I want to basically get a Jedis connection, which is basically a pooled connection resource that's coming in from like our Jedis pool. Same thing for anything else. If you have a pool of Redis connections, it's just basically keeping connections alive. If you have, if you're using TLS, so if you're using Redis Enterprise or if you're using like Amazon, you have the ability to basically do the TLS connection. Now in Redis 6, you have TLS as well. So for this, if you don't want to think about how to pass authentication back and forth, all this stuff can be abstracted out so that engineers don't actually pass passwords into their source code. But at the end of the day, all you have to really do to use the actual, what we just showed. So this Jedis method is now right here. So we have this notion of a Redis service in some of our source code. I was calling it Redis source before. So redis.jedis, I want to fetch a string from a set using a binary key, and then I'm going to pass in some other kind of data. So in this case, before we showed a connection. So this is actually showing something from like actual source code that we have. So it's just not showing anything cool from that source code because that's private. But this is basically showing how this stuff actually works in the real world. So a lot of things like getting a pooled resource, what happens under failure is all kind of done behind the scenes. So you don't have to actually think about that. So everything else is just kind of written like you would like a normal API access pattern or kind of local data access pattern. That's pretty much it. I got 23 seconds left. So thank you everybody for that. So cheers.